Hello everyone, I'm Sensor. In this video, I'm going to present my final project with the title Face Super Resolution with Large Face Pose Variation. Face image often corrupted due to far distance, out of focus or bad quality imaging sensors such as surveillance cameras, mobile device, etc. This leads to blur and low resolution face. Furthermore, the demand of high resolution images are high and continue to grow. This not only because of consumer sense of perception, but many downstream tasks also require high-resolution images, for example, face recognition. This motivates the problem of face super resolution, or FSR. FSR in general is a technique that produces super resolution or SR images by trying to recover high-quality facial information from low-resolution or LR input. With the rapid development of FSR algorithms, modern solutions are able to demonstrate superior results in recovering LR input. Recent interest lies in utilizing natural image prior from state-of-the-art pre-trained generative adversarial network or GAN for restoration tasks. Some of the recent novel FSR solutions are GLEAN, GPAN, and GFP-GAN. The FR result of these works are shown here. Despite recent improvements, the extreme face pose LR input remains challenging to the FSR task. It can be observed that the performance of SSR declines dramatically when face pose is large, especially face pose that are more than 45 degrees. To address this problem, my work can be mainly separated into two parts. First, I perform analysis and fine-tuning on a novel FSR algorithm, namely GLEAN. And second, I propose a new corrupted face dataset. Now I'll be going through the first part, which is analysis and fine-tuning GLEAN. I will first briefly introduce GLEAN. Generative Latent Bank GLEAN is a novel solution of large vector image super resolution task. It uses a encoder bank decoder architecture. As mentioned previously about the current trend, the main idea of GLEAN is also utilizing natural image prior from pre-trained generative model. The generative model in GLEAN acts as a latent bank or imagery dictionary to provide prior for texture and detail generation. On top of that, GLEAN exploits multi-resolution skip connections to ensure produced output can preserve the structure information of LR input image. For the analysis, I tested GLEAN performance on large face pose images. Here is some SR result from GLEAN. From the result, we can conclude that the problem of GLEAN on large face pose are inappropriate frontal face detail, as well as sharpening effect and lack of large face pose detail. To resolve the previously mentioned problem, I conducted an experiment on fine-tuning GLEAN with high-quality large face pose images. However, large face pose images with high quality are rare. Hence, to increase the amount of trained data, I apply FSR inference on medium-quality face images that has a large face pose. Although FSR model fails to produce a good result on large face pose LR image, the performance on medium quality input is still acceptable in some cases. However, manual filtering out the bad result is needed. The FSR model used to produce the training data is GPAN, as GPAN has lesser artifact compared to GLEAN from my observation. This slide shows the final SR result of fine-tuned GLEAN. It can be clearly see that the result has richer large face detail and shape. Furthermore, the sharpening effect is alleviated. Next, I will be going through the second part of my work, which is face dataset. First, I will briefly talk about the objective of this dataset. This dataset wishes to provide a large dataset for real-world face images for evaluation FSR model. It also wishes to encourage the FSR community to focus on challenging LR faces such as small scale, extreme pose, and heavily corrupted old photos. Furthermore, it also which to allow easy comparison of FSR algorithm. This cropped datasets contain over 200,000 single-phase images with large variety in pose, appearance, scale, and lighting condition. To achieve easy comparison, I further clustered the dataset into 3 groups of size: small, medium, and large, as well as 3 groups of phase pose: left, center, and right. Images of this dataset are crawled from the internet using Google and Flickr based on 22 keywords brainstormed by me. The keywords were selected such that the collected images have many faces, less occlusion, and various face pose. Some special keywords are targeted for old-time images that are monotone, for example, old family and Volvo 2. Examples of collected images from some keywords are shown here. Faces in each image crawled from previous state are then detected and cropped down. 40% of the breakdown around the face are preserved. The face pose of each face is also detected and recorded. After cropped, face images are aligned properly. Some examples of final cropped face images are shown here. To conclude, first, I demonstrated Glint fails to recover natural and photorealistic SR face on large face pose despite its powerful performance on frontal face. Secondly, to fine-tune results, I proved that Glint is capable of learning large face pose structure and the performance can be improved. Lastly, I introduced a cropped face dataset that separated in different scale and face pose for evaluating FSR algorithm. Thank you.